Hey everybody, Mr. Ort here doing a voiceover of my video which seemed to have been corrupted from the use of time and space. So today, most of you have already gone through this with me. But for those of you who have not, or perhaps in a different class, here is the fix video. So today we are going to be going over how to balance a chemical equation and some of the simple basic rules here. You cannot break up a molecular formula. So H2O2, H2O, those are all formulas for different types of molecules. So you cannot change those. So we're going to be messing around with other ways of fixing this chemical equation. But the conservation of mass states that you cannot either create or destroy an atom. So looking at this chemical equation, the skeleton equation, we have H2, which is represented by the two blue beads. We have O2, which is oxygen gas. And that's going to be represented by the pink beads. And then we have H2O, which is represented by two blue and one pink. Now, when you are balancing a chemical equation, you are not allowed to break apart those groups. They are together forever. Now, quick reminder, subscripts, those little numbers down below, those go to the symbols directly behind them. So H2, the 2 goes to the H, and if you look at H2O, the 2 only goes to the H. There's only one oxygen in water. As we continue to go forward with this endeavor, we have a middle symbol right there. That's the yield sign. The yield sign tells us basically where the split is for the chemical reaction. So on the left side, we have our reactants, and on the right side, we have our products. And as they combine, they will form the wonderful water. Now looking at this, we have a little break in what we're trying to do. Pardon the pun. But we have two blue beads, two red beads, or pink beads, and two blue and one pink on the other side. So the beads in this do not match. So what we're looking at here is essentially a big old problem. The law of conservation of mass says if we have this little line here, everything to the left of this line has to be even to everything on the right. You can't add extra atoms. You can't subtract atoms. You can't change the color of the bead. So you can't really mess around too much with all of that. As you look through, though, when we try to balance this equation, we're going to have to start off by counting out the number of atoms. So on the left, we have 2 hydrogen atoms, which are represented by 2 blue beads. We also have 2 pink atoms, which are oxygen. On the right, we have 2 blue and 1 pink. So looking at this, the law of conservation of mass is not happy. So this chemical equation is broken. So what we're going to need to do is we're going to need to fix this. Now, we can't just take a pink away. We can't just add an extra pink. The only thing we can do is add groups that already exist. And the way we do that is by adding a coefficient. So if you look at this right here, there's not really too much we can do as far as that goes. So we'll add this big old coefficient, and just like in math, that coefficient is going to equally distribute to both hydrogen and oxygen of that groups. So think of it as like in math, there's a bracket there. So that 2 goes to the hydrogen, and it also goes to the oxygen. And what ends up happening is you get 2 times 2 hydrogen, which is going to be 4 hydrogen. And we get 2 times 1 oxygen, and you get 2 oxygen. So now we have 2 oxygen on the right, 2 oxygen on the left. We are going to be happy. I'm going to represent this by adding a group of beads. So again, you can't change the number of atoms of either the molecules, but you can add more groups. And that's just called adding a coefficient. So we have 2 groups of water. So our pinks are happy. So we have 2 oxygen, 2 oxygen. Happy, happy, happy. But our hydrogen isn't happy anymore because we have 4 on the right and we have 2 on the left. So, spoiler alert, what do you think we're going to do? If you said add a coefficient, you are correct. So we're going to add a coefficient, and we're going to get 2 groups of hydrogen. We'll throw that down for you. Now, as we do this, I like to circle up to actually see what those coefficients actually look like. So 2, that means we have 2 groups of those. We have 2 groups of the water. And then what does it mean if there's nothing there? Well, it's actually just a 1, because if you look up above, we still have 1 group of oxygen. And now, double check, we have 4 hydrogen, 2 oxygen. We have 4 hydrogen, we have 2 oxygen on both sides. So hydrogen's now happy. And ba-ba-da-dum, the equation is balanced. That's essentially what you're going to be doing. There's a lot of different methods to do this. This is just the first type, which is kind of, I refer to as the Sudoku method, aka the trial and error. You just plug in groups until you find the correct answer. So this is a way to do it. Otherwise, there are other videos showing other methods, and you can always invent your own. So that is that. Balanced equation set.